Astronomers can see a star blow up about every 30 years. It's not every, no, it's not like it's on a timetable. It might be every 5 years, might be every 50 years, but on an average, every 30 years, a star explodes. And they're looking out there with their telescope and say, oh, wow, there's a new one. A star exploded. It's called a nova, or if it's a big one, they call it a supernova. Nova in Spanish means no-go. By the way, the Chevy Nova did not sell very well in Mexico for that reason. Hey, do you want to buy a Nova? No. Why would I do that? It won't go. But stars blow up every 30 years. Well, they've searched the heavens with these telescopes looking for how many supernova rings are there. They call it a dead star. Or they can find less than 300. Now, wait a minute. If there are less than 300 supernova rings, and one happens every 30 years, you can do the math. I mean, that's about 9,000 years. If the universe is billions of years old, there ought to be a whole lot more supernova rings out there. Why are there less than 300 supernova rings? Because it's less than 10,000 years old? Boy, they don't like that answer at all. But that's the logical conclusion. Anyway, if stars are blowing up every 30 years, we would have to have at least one star born every 30 years just to keep the balance. I mean, countries that have a population problem because they're getting less births and deaths, like Germany, more people are dying than being born. Oh, well, eventually that's going to create a problem, okay? Stars should have to be born. Nobody's ever seen one star form, not one. We see them blow up all the time. They've never seen a star form, and I'll cover that in a second. Its last estimate by Hubble telescope was that there are 70 sextillion stars. 70 sextillion. They say the universe is 20 billion years old. Well, you can do the math. That means 6.5 million stars would have to form every minute. We'd have to have 6.5 million stars forming every minute for 20 billion years to make the stars that we know about. That doesn't count the ones we don't know about because we can't see them yet. Who knows how many stars are out there? Sometimes the textbooks will say, well, there are new stars being constantly born in clouds of gas and dust. This is so stupid. How a physics textbook can teach this, I don't know. Anybody that knows freshman physics knows when you try to squeeze gases together, pressure builds up, temperature builds up, and it drives them back apart. It's called Boyle's gas law. Nobody has ever seen dust collapsing into a solid. It would take such incredible pressure to do that. Anyway, second question. Is the sun shrinking? There has been some controversy among creationist groups in the last 10 years over this question. The sun is shrinking. There's not much question about that. But does that prove it's not billions of years old? Well, I think so. The sun is burning, obviously. You can step outside and look at it. It's losing about 5 million tons every second. Quite a weight loss program. Well, that means, of course, it used to be bigger. You don't need to be too much of a genius to figure that out. Bulletin of American Astronomical Society ran an article back in '79, which some people have argued about the legitimacy of this, but they said, since 1836, more than 100 different observers at the Royal Greenwich Observatory, that's in England, and the U.S. Naval Observatory have made direct visual measurements that suggest the sun's diameter is shrinking at a rate of 0.1% each century, or about 5 feet an hour. Let's assume that is correct for the moment. If the sun is burning and it's losing 5 feet an hour, that would be the diameter. So the radius would only be 2.5 feet of radius. It's 93 million miles to the Earth. You divide that by 2.5 feet per hour, you're going to find out it cannot possibly be billions of years old. That, of course, would assume several things. Has the rate always been the same? Has the rate of burn always been the same, et cetera, et cetera? I know there's a lot of assumptions built in. But I think we could all agree the sun is burning. I think we could all agree it's getting smaller. Several indirect techniques also confirm the sun is shrinking, although these inferred about 1/7 as much from Science magazine. Here's a chart showing the graph of what has been observed, written down. I mean, they look at the sun, they measure the diameter using trigonometry, and it's close enough to work that way. That they measure the numbers and say, wow, the sun's diameter, polar and equatorial, is shrinking. Now, I know the sun oscillates. It swells and contracts and swells. It's burning like a marshmallow, But generally, you can see from the graph, it is losing diameter, losing size. Well, if you go back billions of years, you would assume this would make a problem. If the sun were bigger, it would pretty soon absorb Mercury and then Venus and then Earth. I don't know how far back it could have to go. The bigger problem, though, than just the size of the sun is the mass. Gravity is directly proportional to how heavy the objects are, the mass of the object. If the sun were more massive, gravity would be stronger, and that's going to start sucking planets in, drawing them out of their orbit. So yes, the sun is shrinking, and I think it creates a problem for those who want to believe the universe is billions of years old. I wouldn't put a number on it, but it certainly makes a problem somewhere.
Earth. It's awesome. The way everything fits together and operates, we take it so for granted. Let's look at Earth for a second. Earth is slowing down at about 1.5 milliseconds per century. That's not a lot. It's about 1.5 seconds every 100,000 years. That means that the Earth was spinning a lot faster a long time ago than it does now. If man came into being about 3 billion years ago, then as you can see by these calculations, our day would have been about 11.5 hours long. Can you imagine how fast the world would be spinning then? There's two things would happen. We would either be thrown into space at quite a speed, or the gravitational pull of Earth would be so big that we wouldn't be able to stand up or move or do anything.